Welcome to the Supermicro Green Series on the top 10 best practices for creating and implementing a green data center. Supermicro is known as an industry leader in green computing and offers a wide range of energy-efficient servers. Globally, data centers use between 1% and 3% of energy today. And this is expected to increase significantly over the next few years. In addition to saving energy, e-waste can be reduced with the proper planning and execution when looking at new servers. There are a number of actions that IT administrators and data center operators can take to reduce their energy consumption. I am Michael Schulman, and I will be your host today. I'm here with Vic M., who is our Senior Vice President and General Manager here at Supermicro. Welcome, Vic.
Thanks, Michael.
So you interact with customers a lot. What are some of the questions, what are some of their concerns about the right components in their servers?
Technology as it is transitioning, and you can see a lot of new technologies, whether it is on the CPU or the GPUs or accelerators, networking gear or storage front. All these things is actually confusing to the customers. It's more of a challenge than a confusion also, if you really think about it, mainly because with all these things, which one they should choose, what actually solves their problem in a way where they don't have to necessarily break the bank, but at the same time, it actually helping them to do their business more optimally while taking care of all the other aspects of it.
So customers have specific workloads. What are the decision points in terms of the components that they should be aware of when kind of putting together what they need?
So Michael, I think what is happening, as I say, industry is evolving, right? So you see the customer base, there are cloud service providers, tier 2, tier 3 types, and they have enterprise customers. There are smaller data center that are distributed a lot more than what it was a few years ago, which is actually driving a different type of adoption of the platforms. So if you take a look at it, energy is of utmost importance, right? Because you think about especially countries like in Europe and Asia, where the energy costs have shot up a lot, and they need to make sure that they have to keep that in check. That's number one. But at the same time, people need to look at what kind of a workload that they have to use on which kind of architecture. So if you use the wrong platform for that, it may do. Like it's like taking a Ferrari for a grocery store, right? Yes, you can buy groceries, but is it the most optimal? Or taking a family four-seater and taking it onto a race course, it's just not going to work. So if you take a look at on the compute, of course, processor optimization need to be done for the workload, and more GPUs are going to be used, and which ones to be used, and what kind of workload does better on that. And last but not least, adopting what kind of a storage architecture, whether it is using with the traditional spindles, or they want to be looking at some kind of a flash. All these things and how they are interoperable, what kind of operating system that will be running on it, what kind of applications that accelerate and do better. It is a problem that they are trying to solve, and we are trying to work with them to see what kind of things that we can put in front of them and how we can put validated solutions so they can take it and run with it.
So at each of those decision points, let's take GPUs and CPUs. GPUs are faster, so in the big picture, how does that reduce power consumption?
So performance per watt. Long gone are those days where people are looking at pure performance or performance per dollar, because performance per watt is important as people are trying to pack that performance in a small form factor. Because right now what's happening, you have a rack has a limited power, or you have a data center has limited power. So it is not just the cost, but within that power footprint, what is the maximum that you can get out of? So as more and more application developers are optimizing their software on the GPUs, now all of a sudden it opens up these heterogeneous compute deployments where, again, depending on what people are trying to use, if it is a standard compute or people can take advantage of the accelerators, they are actually using it, which overall, when you take a look at it, what is it's going to cost them to do their operation in a most optimal way within a given power budget. So GPUs are becoming extremely important in the overall ecosystem.
Right. So the GPUs use power, but in the end run, the application runs much faster.
Absolutely. I think again, performance per watt. You see that even the GPUs, what used to be 200, 300 watts, now going into even like 600 or 700 watts. as we do that, how much more performance we can get out of it, and if it actually makes sense, if you can do more with less, when I'm talking about on the power footprint or whichever, I think that's what we are driving.
Now on the storage side, lots of people are moving to SSDs. One reason is performance over HDDs. What are some other reasons people are moving to SSDs?
So, few things. Number one, the less moving parts, more reliable they are, more efficient, better performance because of the nature of it. So we are talking to customers, and customers are looking at hey, what kind of things that I should be worried about? I want to run the systems for a longer period. So endurance become important, power consumption becomes important, overall performance that you can get it, and when we do all these things, what kind of platforms that they need to take, where they can actually take it at the upfront, or if it is a cloud service provider and whatnot, they can figure out a way to increase the capacity. We are seeing reasons for customers to elongate the life cycle of the product. We are talking about, think of Supermicro's application optimized type of portfolios, where we are putting higher endurance power supplies and higher longevity on the CPUs, as well as the flash memory, NVMe in this case precisely. This actually makes the system run efficiently for an extended period of time for more, let's say, demanding workloads. Overall, it's going to actually help them, and that actually is quite exciting.
So with all this new technology, you can get more performance per watt, which reduces the amount of power consumption, and you talk to customers a lot. How does that relate to the PUE of the overall data center?
Oh man, I tell you, this is the most exciting part, right? Because you take a look at it, not all data centers are created equal. Not all geos operate the same way. Europe has the GDPR regulations, very sensitive to power. And then when you take a look at the larger scale data centers, where the scrutiny from the government, as well as the companies trying to focus on energy efficient compute, all these things, when you take a look at, the efficiency portion coming out from that becomes a lot more important. And when we are getting the right component that is specced into that, whether it is memory bound application, compute bound application, heterogeneous compute, or if it is a cloud service provider with various workloads, how we are trying to bring it back into the game is extremely important. And to take it a step further, open architecture. So we are talking about being able to take this and provision easily. Think of like a super cloud composer or open APIs such as Redfish API to integrate into their data center facilities. All these things will make efficient use of the available systems, and based on the way the data centers are designed, if the systems are able to operate at a higher ambient temperature, or even if it is not, by incorporating some kind of a liquid cooling and whatnot. Overall, in the past, people are used to be looking at only the cost of the equipment. Now they are looking at the overall cost of ownership, in which case bringing the PUE down will help them to use the energy more efficiently, bring the cost down, and be able to pack more punch and scale their business. Let's almost double. If you think about a few years ago, PUE used to be like a 2.0, which is normal. Now people are driving towards 1 or even lower than 1. The balance is going to be on selecting the right hardware with the right components that actually brings the endurance and performance without compromising on anything else.
So you run an organization that works closely with customers, and you're able to consult with them to help them bring their PUE down.
Absolutely. I mean, take a look at this PUE part. It's at a system level and as well as a data center level. And depending on whether they are using only a specific vendor equipment or multiple vendors. Oftentimes it's multiple vendors, so we need to talk to customers on what are the capabilities or limitations of the data center, and how do we basically spec the right platforms into that, so they don't necessarily need to reinvent the wheel, but at the same time they are not vendor locked, but they can take advantage of what we have to offer. And within the platform, it's an exciting topic, mind you. So within the platform, if you take a look at it, what used to be a standard NVMe drive, now you're talking about M.2, U.2 or U.3 drives, E1S, E1L, and E3S. You are talking about getting a scalable architecture that is extremely power efficient, and depending on what kind of flash that you use, think of like a TLC or a QLC and the software that runs along with it. In every aspect, I'm just talking about flash here, but that kind of goes into the compute, which kind of processor architecture, which kind of accelerators, all these things. when we are able to validate and bring the right platform to that, which will tremendously impact the PUE of a data center and also impact how efficiently the businesses are run. So it's a good time to be in.
Okay, well, that's a lot of tremendously just great information, Vic. Thank you very much for being with us today and explaining all the different steps and effects of how to green your data center.
Thank you. Thanks for having me here.
Supermicro recently published a white paper based on a survey of over 400 IT professionals. This white paper discusses 10 actions that they are taking to reduce their environmental impact of their data centers. You can download the white paper from our Green Computing website, which we will mention at the end of this webinar. Data centers have a significant impact on the environment. It is estimated that 400 terawatt hours of electricity are used annually. An estimated 2+ million tons of e-waste are generated by data centers worldwide each year. Although renewable energy is gaining momentum in many areas of the world, there are still some geographies where 80% of electricity is generated from fossil fuels. And we estimate that up to 8 billion trees would not have to be planted each year for carbon offset if data centers worldwide would adopt some of these green computing best practices. To learn more about Supermicro's green computing solutions, please visit www.supermicro.com/greencomputing. Thank you.